Oh, now we're live. Look at that. That's awesome. Hey, Brandon.
Hey, how's it going, Ari?
Hey, long time no talk.
Yeah, it's been forever.
Yeah, you were talking about moving, and the funny thing is just 30 days ago, I didn't have any of this on my wall. And
Oh,
I
yeah.
moved into my home like in May of last year, and it wasn't until the last 90 days that I actually ended up with anything on my walls other than like whiteboards. Like that's the first thing that went up, and then
Yeah.
that's enough. Okay, it's cool. I can do this.
I know. It's interesting in this age of all of us being at home and having being online because of that. Yeah, it's you almost feel that need to have cool decorations behind you. Like I don't know if you caught the Ignite Microsoft Ignite conference keynote yesterday, but
No, I didn't.
Well, Satya Nadella, the CEO of Microsoft, was speaking, and
Yeah.
he had shelves behind him with toys and trinkets on it, and that just started a whole Twitter rabbit hole of people trying to figure out what's on the shelf. And
With the Xbox thing.
I think he had a baby Yoda on there. But yeah, my walls are still blank. We just moved into this house a couple weeks ago to essentially move to the suburbs, getting away from, we were living in San Francisco, and it's just not fun to live in a big city, especially living in an apartment during a global pandemic. So now we have a backyard, and life's just a little bit better.
Yeah, I think I know what you're hiding in the background there, and that's the .NET Maui preview.
I wish. I can't wait. Although
because
there's
nothing there.
I gotcha.
My joke.
I mean, I do have that queued up for today's talk, though. We'll touch on that just a little bit.
Did you see my presentation about that? I did a whole thing about it.
No, I didn't.
I'm super excited about that.
Same.
I think it went well. It was virtual, so no one could throw anything.
Yeah. You can say it went as well as you want. Like, you got a standing ovation.
There were no complaints.
That's right.
Everyone was really cool about it. It was
perfect.
I wonder what the delay is on this. I'm going to mute for a moment so I can see what the. So it says like 7 people are watching right now. Hey, Xamarin does it. Sweet.
About 20 seconds.
Yeah, it's not that bad actually.
Nice.
This is fun. So, yeah, the whole Maui thing. Maybe I'll talk with you at some point, maybe offline. I got a whole bunch of cool Bluetooth stuff I want to consider doing. I'm curious what your thoughts are about how best to approach that from a cross-platform perspective on Xamarin. But
that's a good question. I've never done Bluetooth myself.
I have.
It seems to always be painful whenever I hear anybody talking about it. Is that how it was for you?
So the one time I did Bluetooth integration in a Xamarin app was in like 2012.
Oh, when that's probably back before Bluetooth LE.
You had to pay like $1,000 or whatever for the Xamarin license.
Yeah, back in the good old days.
I was building an app that via Bluetooth. This is before BLE. Over Bluetooth would inflate and deflate shocks, and it was really cool because I had to figure out. Oh, there's a question coming in about Maui. I had to figure out how to do this in a nice threaded way. Otherwise, you'd lose the app crash. And this is all before Xamarin.Forms. Like Xamarin.Forms would have made this so much easier from a UI perspective. But instead, I had to like build the zibs and nibs and all the other insanity, I was just like, but at least Android, at least iOS develop, or pardon me, at least threading was simple with C sharp. Like, try and figure
Yes.
that out with like Objective C. No,
No thanks.
man, like I'm like, oh, this is so much better. It's so because I can so easily handle all of this. From a Maui perspective, it is an evolution. It's an evolution of Xamarin.Forms, and what the cool thing about it, I think, is, and if you watch our previous presentation about Maui, it covers kind of like how we got to Maui, and really how we went from the mess that was Microsoft development of insert anything with an X at the end of it here, and then all the UI approaches that Microsoft's had over the years, and finally seeing consolidation happening with .NET, and then finally seeing cross-platform being a thing with .NET Core, .NET Standard, and Xamarin, and seeing all this stuff come together, and Microsoft going, hey, you know what? .NET should be everywhere, and we need to take this cross-platform stuff seriously, but we also need to, kind of like we've consolidated the libraries and the API surface, let's start standardizing the UI. And Maui gets us there. Now, it's not going to be around till 2021. That's the current estimate. With .NET 6, my understanding is that with build this year in November? No, .NET Conf in November is when they're going to release .NET 5 with, we hope, an alpha or a beta version of Maui. Okay,
Fingers crossed.
It would come along with .NET 6 in some form or another. Now, my hope here, I haven't played with Uno yet, but I don't think Uno's from Microsoft. Stop me if I'm wrong about that, Brandon. It seems like a really cool approach, but I can't talk about it only because I haven't played with it. But when I looked at it like a year ago, I was like, oh yeah, that's cool. And keep in mind, you don't have to switch to Maui right now. And first of all, it doesn't exist. So Maui is an extension of not extension of, but it's an evolution of Xamarin.Forms. So you don't have to immediately move, right? Well, I mean, Microsoft's not a country, but yes. I'm joking there. Hopefully everyone laughs. It doesn't take me too seriously. But it'll be interesting. I think the ultimate thing would be if Microsoft started really taking consolidation seriously on the UI front and got rid of WinUI 3 and just said we're going to go all Maui, and have a standard way of handling UI in .NET Core, .NET. I think that would be great. I hope that's where it's going. But hey, the cool thing about .NET is it's so extensible. I think as long as like the standard framework is just consistent, which is where I think we've gotten to, then you can do whatever you want. Xamarin doesn't require you to use Xamarin.Forms. That's not a requirement. So if you want to use MVVM crossed, if you want to use the mobile Blazor bindings, if you want to use Maui and everything it offers, if you want to use Prism or a mix of any of these, if that's possible, it all depends. You want to use Uno, that's your prerogative. I don't think Microsoft's holding you hostage to their technology alone.
Yeah, I mean, circling back to Uno, I haven't played around with it either. It is built by developers based in Montreal, but essentially Uno, you can think of Uno as similar to Xamarin.Forms in that it's a cross-platform UI framework. Mm-hmm. It actually runs on Xamarin, just like Xamarin.Forms does. But the difference is that Uno uses UWP XAML. And so the really cool benefit with Uno is if you already have a UWP app, you could essentially leverage that same app that already exists for UWP and make it cross-platform using Uno. One of the big things that Uno has that Xamarin.Forms does not is, I guess we'll call it web support. I'm not a web developer. I already actually just built my first website ever. Like, I had to do an internal site that's very, very ugly. There's no CSS or anything, but it's functional. I built that this week. But yeah, the cool thing with Uno is it leverages WASM. So that same cross-platform app that will be running on UWP, on iOS, on Android, using Xamarin will also run on or in the browser. Yeah. And I'm not sure what engine they're using, but if it's WASM, I would imagine they're doing something. Are they doing something with Blazor?
I don't know, but I know that I was in our meeting about Blazor a few months ago, which, by the way, there's an Indy.NET consortium talk about Blazor. So if you look at my other meetup, which is the Indy.NET consortium, Nick George did a whole thing about Blazor. And cool. I don't know if the two teams have worked together, but if you take a look, he does talk about that.
Right on. But yeah, Uno's great stuff. And kind of like you mentioned earlier, Ari, like it leverages and uses all of the Microsoft suites. So of course, Microsoft is not just okay with it, but encourages it because it gets more people using the .NET stack, using the .NET tooling like Visual Studio. So yeah, it's definitely a welcome addition to the .NET community.
And this is cool. Like I'm refreshing my memory about Uno. I mean, if you're looking at it, and I don't know, Balahi, is that how you say your name? I don't know if Objective-C, yeah, that is a brutal language. I'm trying to remember what I was going to say. Yeah, I think what Xamarin.Forms really offers you, and it seems like Uno would offer you as well, is yet another presentation tier. Solution for your presentation. So, I think if you have everything architected properly for your business objects and just the supporting architecture of your application, you can mess around with the presentation tier almost any way you see fit. As long as you're not hard coding, like hard dependencies on everything. If you code with intent, I think you can play with all of these and see what works best for you. Microsoft seems to be going in the Blazor direction. And by the way, we need to get started here in a minute, but I'll answer.
Sure.
I just looked at the clock. I'm like, oh no. I planned on starting at 6:40.
Welcome to today's meetup about Uno.
about everything. Yeah, it's we call this the 42 presentation. Yeah, but again, I gotta stress that you're not stuck with Blazor or Xamarin.Forms or Microsoft's technologies when it comes to that presentation tier. You're stuck with the platform in the sense that or with the framework, but that's not a bad thing. You can't call yourself a Microsoft developer and not buy into the framework. That's just part of it. But I think if you treat these as presentation tier options, then it might work out better. But that's my thought on that. So let me get started. Welcome to Indy Xamarin. Happy to have everyone here. We got a great presentation lined up for you tonight with Brandon Minnick. Am I saying it right, Brandon?
Yep.
Awesome. And Brandon knows everything about everything, and he's going to present. So we meet every month on the fourth Wednesday. And we've got a lot of topics. If you take a look at the Meetup site for Indy Xamarin, we record every one of our presentations. So if you missed anything or you're curious about what we've talked about, we've covered everything, not just Xamarin.Forms, but we've covered why you might choose Xamarin. We've covered Xamarin Essentials. We covered .NET Maui last month, I think. I think it was last month. We've covered M-Fractor. We've covered a lot of different things. So, definitely hit up the Meetup site and you'll see the links. to all that stuff. We usually post a copy of the presentation within a day or two of any meetup. So if your friends couldn't make it, no harm, no foul. Please invite them to our site so that they can take a look and learn. So let's see if I can flip to my slides here because I have all these different screens. Yay! A special thanks to our sponsors, Sandy Solutions, that's our big sponsor, and Launch Fishers, which when we're not meeting virtually, we meet at Launch, which is a co-working space. Mfractor, which if you haven't used, it's like ReSharper for Xamarin Studio, for Visual Studio for Mac, or it's like ReSharper for Xamarin, really, because now Mfractor is cross-platform. It's available on Windows and Mac. And then Rev Debug, which if you haven't used that, it's a really cool tool. It does for debugging what ReSharper does for writing code, and I don't mean makes it slow. It's a really cool tool. Like you could record your entire Xamarin debugging session and then step through it line by line with state recorded. So you can find all the exceptions that occurred and see them in a timeline, just like a video player. So very cool stuff. Tonight, as usual, we're one of the many meetups that are part of the .NET Foundation. If you haven't joined the .NET Foundation, just definitely check this out. They run the .NET Foundation virtual user group, which is phenomenal. There's meetups going on every single day across the globe, and the .NET Foundation brings all that together in one place. So we got meetups all over the place, but you can sign up for the one .NET Foundation virtual user group, and it'll let you know when new topics of interest are coming out, and it'll link to groups like ours. So you might be here tonight because you heard about this from the .NET the .NET Foundation virtual user group. If you did come that way, yay! Thank you for joining. Please also hit us up on Indy Xamarin on Meetup, and subscribe to our stuff. Click the bell, subscribe, and like. Kidding. Although I don't think you can do that when it's just a live stream like this. Again, very excited to have Brandon here tonight. If you have any questions, I'll be monitoring the chat window that's coming through, and I'll make sure to bring those up to Brandon because he's not going to be able to see the chat possibly while he presents. You might be able to. I think StreamYard might show some of it, but there's like a 20-second delay, so I can tell you once I see it. But please feel free to answer questions or ask questions anytime during the presentation. We'll try to get them answered. Sometimes it might take a few minutes. And with that, take it away, Brandon.
All right. Perfect timing. I was just logging into the app that I'll be showing off today. So
awesome.
I was hoping to sneak that in really quick so I didn't risk sharing any passwords with the world. But we're already showing my screen. Look at that. Whoops. Let's go back then. Okay. Awesome. Thanks so much. Yeah. Thanks everybody for joining us today. And Ari, thanks for having me. It's always a pleasure hanging out with the Indy Xamarin user group. And today's talk is all about architecting Xamarin.Forms apps. And actually, before we get rolling, Ari, how much time do we have? When's the stream end?
Sure. So we usually go for an hour to an hour and a half.
Okay, cool.
That's about what people are comfortable with. It is getting into some people's evenings, but of course, if you miss any of it, it's all recorded. So yay.
That's right. Okay, good to know. Yeah, just curious because happy to hang out with everybody. Answer as many questions as we can get. Like I already mentioned, if anybody has any questions, drop them in the chat. Ari, you're right. I won't be able to see them because I'll have my slides up or I'll have code up. So feel free to jump in anytime. We want to keep this as interactive as possible because, at the end of the day, I already know what I'm going to say. I already know all this stuff. So I'm more interested in answering your questions and trying to help connect the dots on maybe some new topics. So feel free to drop any comments. Ari will chime in anytime. We'll have a nice conversation today. But yeah, we're going to be covering a lot of stuff because when Ari reached out and asked me to chat about architecting Xamarin.Forms, the scope of this talk in my mind just started growing and growing because there's so many buckets that architecting falls into. Because one of the cool things with Xamarin.Forms apps, obviously, is they're cross-platform. They run on iOS and Android. And so there's, how do you architect that to make sure we have this cross-platform experience? We have shared code. And then branching out from there, there's things like running UI tests. So UI tests is basically code emulating a user. So if a user can tap a button, we can write a UI test that can tap a button, that can enter text, and essentially emulate those user workflows. There's unit testing, which, we're all responsible developers, so we always write unit tests, right? And how do we architect our unit tests? And then one of the cool things with Xamarin being in C# and C# having such a strong backend presence for things like APIs and websites, web servers, is we can even share code between our mobile app and our backend. So there's going to be lots of layers in this talk, and I'll keep an eye on the clock to make sure we can touch on everything, because I know we chatted about Maui a couple minutes ago in the intro, and I included, one slide to give kind of a sneak peek of what architecting will look like in Maui. So let's jump into it. There's a couple slides. We'll be mostly looking at code today, but what I want to point out is 2 links that you'll see on the bottom of just about every slide today. So the bottom left, that is my Twitter handle, The Code Traveler. If anybody has any questions, feel free to tweet at me or shoot me a direct message. My direct messages are always open. I'm always happy to chat about Xamarin, .NET, C#. I used to work at Xamarin. That's how I made it to Microsoft when they acquired us a couple of years ago. And so I'm definitely a big fan of Xamarin. And on the bottom right, this is where you can find the source code for everything we're doing today. There's an app that I'll do a shameless plug right now called Git Trends that I built. Oh no. Huh? I hit my API limit. That's okay, because Git Trends has a demo mode.
Ship it.
So, well, ironically, this is in the App Store today. So I'll tell you what, I'll just show you what gittrends.com, spell it right. So this was an app that I created actually about a year ago as just an app to help me, because I love the open source community. I have tons of open source repos. I think at last count, I had over 300. Now, it's not that they're all being actively maintained, but a lot of them are. And so one of the problems I was having with all my open source repos was just keeping up with them and how to manage them, because what I found was I had some repos that I hadn't touched in years that I found were getting a lot of traffic. So they were still getting 12, 20 views a week. And this was source code that folks were referencing for their apps. And so I wanted to be able to stay on top of which open source repos of mine are getting the most traffic. That way I can make sure to keep those up to date. So I created this app called Git Trends. It's available in the iOS and Android app stores. Shameless plug, like I said. But what we're going to do today is check out how I architected Git Trends. And with everything we're chatting about today, there's always multiple solutions to any problem, no matter what anybody says. I mean, I know some folks are very passionate about architecture and will subscribe to only one way of doing things, like you have to do dependency injection. Well, do you have to? It's recommended, but no, you don't have to. So what we'll do, we'll walk through Git Trends, because Git Trends it's all built in Xamarin.Forms, and it also has a suite of UI tests, a suite of unit tests, and even has a cloud backend. All of it's written in C#. It's all sharing code amongst everything. And so we'll be leveraging a lot of this code. So all that to say, at the bottom of the slide, boop, you will see the link to the source code, gettrends.com, just redirects you to its GitHub repo where you can download the source code, play around with it yourself. So all that to say, don't worry about memorizing anything today because it's all open source, it's all available, and everything we reference is actually linked down below. So there's some cool libraries we'll be chatting about like Refit, SQLite.net, Poly, and all of these are linked in this README. So you don't have to worry about memorizing anything, taking screenshots of links. If you just remember gettrends.com, this is where we can come to find everything. So with that being said, let's jump into the first architecture topic. And this is what I'm calling the mobile app architecture. And if you've done any Xamarin.Forms development, this will look very familiar to you because like we mentioned earlier, Xamarin.Forms is a cross-platform UI that runs natively on iOS and Android. And the way Xamarin.Forms works, to be able to still create the native UI button on iOS or the Android widget button on Android, is that in Xamarin.Forms, when we just say button, well, when we compile for iOS, our code that we called button in Xamarin.Forms gets turned into the native UI button. And likewise on Android, that button in our shared code gets turned into the native Android widget button. Actually, it's probably been updated to Android X, but anyways, this allows us to essentially write our code once and run it on both platforms while still getting the native performance and native look and feel. And so how do we do this? Well, we have we'll say a common project. I didn't want to say shared project because that actually means something, but a .NET project that is common for both iOS and Android. And both these iOS and Android, we'll say head projects, reference that code. So you'll see a lot of these diagrams in the slides today where we're talking about references, and literally what that means is if we jump into our code and we look at, say, iOS, if we click on add references, well, there's a checkbox next to get trends because the iOS app is referencing the code. And essentially that's how we're sharing our code between these two projects. Now, yes, this one's pretty basic. Wanted to share it just in case anybody's new to Xamarin or Xamarin.Forms. But I also wanted to talk about my recommendations for this, which is to use a .NET Standard 2.1 library. There's a couple rules of, well, I guess first, what is .NET Standard, right? .NET Standard is a way to make a C# project that has no runtime. So why would we ever want to do that? Well, in this case, we want to leverage the native runtimes. No thanks, Dropbox. We want to leverage the native runtimes. Like for iOS, we want to use the Mono's iOS runtime. And likewise on Android, we want to use its Mono Android runtime. And so what .NET Standard gives us the ability to do is create a project that has no runtime included. And really all it is just a giant interface that says, here are all these APIs you can access, specifically .NET APIs. So things like system.datetime, well, any system library, really, all those ones we know and love. And there's a contract in place that Xamarin iOS, Xamarin Android, .NET Core 3, etc. have all said, we will support all the available interfaces or all the available APIs in this specific .NET standard. So yeah, basically .NET Standard is just a project that can't do anything, but we can run it on different platforms like Xamarin iOS, Xamarin Android, .NET Core, etc. And so when we are creating our Xamarin.Forms projects, my recommendation to you is to create a .NET Standard library, and then for the version of it, crank it all the way up. the latest, greatest version is .NET Standard 2.1, which I'm referencing here. And that's really all you need to do to get started, because .NET Standard 2.1, what the number means, the bigger the number, the more APIs are available. So .NET Standard 2.1 has the latest, greatest stuff, like iAsync enumerable, async streams, all that fun stuff. And again, when that code gets compiled down, it'll run using the native runtimes for Xamarin iOS, Xamarin Android. Now, you can also use what's called a shared project. The difference between a .NET Standard project and a shared project is the shared project. Let me rephrase that. The difference is that the .NET Standard project, when you compile it, it'll generate a DLL. So for example, if we jump into our code and let's see, if I dig into the outputs for my .NET Standard library, there it is. We have gettrends.dll. So this is a .NET Standard project, creates a DLL. Again, it doesn't have any runtime. This DLL just gets sucked up by whatever runtime we're using. In this case, Xamarin Android here. Boop. And so with the difference with, there we go, with a shared project is a shared project does not generate a DLL. The shared project actually is subsumed from whatever project is referencing it. So what we would see if this Git Trends library was a shared project, it would not generate a DLL. And when we build for iOS, all the code that exists in this shared project would just be built as if it existed in this gettrends.ios library. And so there's some pros and cons there, but the reason I recommend using .NET Standard is .NET Standard allows you to install NuGet packages directly into the library. So if we look at our code here, our .NET Standard, I've got all these awesome NuGet packages from amazing open source libraries here. If this was a shared project, we would see 0 NuGet packages because it's impossible to add them to a shared project. And the tough thing there, and this is the reason why I recommend using .NET Standard, is if we can't add NuGet packages to our shared code, well, then we have to make sure both our iOS projects, which we can add NuGet packages to, and our Android projects, we can also add NuGet packages to, are in lockstep. And I've been burned with shared projects a couple of times where I updated Xamarin.Forms NuGet package in the iOS project and forgot to do it in Android, went to run the same app that worked beautifully on iOS on Android, and all of a sudden nothing worked. So you'll hit weird little things like that. So you can use them. Shared projects are super powerful, but it's one of those things with great power comes great responsibility. So if you're new to .NET, stick to .NET Standard for now. If you have used shared projects before, if you understand those, the power, which that power really just means more opportunities for you to shoot yourself in the foot by accident, which I definitely still do occasionally. If you understand all those things, go for it with a shared project. But if you're new to Xamarin, to .NET, it's hard to make similar mistakes like that with .NET Standard. So,
yeah.
So right. Well, all of our Xamarin.Forms code lives in this .NET Standard library. And if you're only targeting iOS and Android, crank that up all the way to 2.1. Now, the caveat is, what if we're also targeting UWP? Well, UWP doesn't yet support .NET Standard 2.1. So same for everything we talked about. I still recommend using .NET Standard over a shared project. But in this case, our peak .NET Standard level will be 2.0, which is still good. Still has everything everything we need to create a great app. It's just about a year behind, and it doesn't have cool things like async streams or iAsync enumerable, which I know I fell in love with when they debuted. So just something to keep in mind. If we are targeting UWP, for now, we can only go up to .NET Standard 2.0. But if we're only doing iOS and Android, crank it all the way up to .NET Standard 2.1. All right. How are we doing on questions, Ari? Anything coming in? Any fans of shared projects out there?
No, I have something to add about shared projects. I used to always use shared projects because going the PCL route, which is what you used to have to do,
Oh, yes.
was a nightmare, and shared projects got you around that. But that's where I learned about exactly what you said, which is the NuGet versioning nightmare. Like, hey, I referenced one version of, let's say, Newtonsoft JSON example in iOS, and used a feature it has, but I used an older version that didn't have that feature in Android. Well, Visual Studio doesn't know what doesn't exist in each project. So the shared project overlays those projects. So basically, it's like all the files that are in that shared project are part of both the projects that are referencing it. So it's kind of like they're injected as if they were part of that project. The problem is you run into a lot of compatibility issues there. You also run into, and I 100% agree about going the .NET Standard route. We're getting some questions in. Yay.
All right.
A couple things there. One, I think you'd be safe going .NET Standard 2.1 in iOS and Android, but you got to have the shared libraries have to be the lowest common denominator. So you'd have to have .NET Standard 2.0 for that head project that you're talking about that contains everything. But the iOS and Android, I think, could be 2.1 because they can reference 2.0, but you can't go the other way around. But be very careful if you go the shared project route. You're going to have to get used to compiler directives because you're going to have to know about if the platform is iOS, run this code. If the platform's Android, run this code. And your code gets real ugly real fast. So if you can stay away from shared projects, I've learned to stay away from them. Okay. Questions. When ASP Nerd asks, when will we move from standard to core?
Ooh, that's a good question. And we'll touch on that later when we talk about .NET 6 and .NET Maui towards the end.
Yeah. And at least on VS for Mac, so Visual Studio for Mac. So John asks, at least on Visual Studio for Mac, I don't think there's even a template for a shared project anymore. I imagine you can still create one, but it might not be so straightforward. Well, my thought there is good. Explaining shared projects, it's magic. And I think they had their place when you had PCL, but I don't think they had their place now that .NET Standard exists.
Well, funny you mentioned that, because later I'll actually give you a recommendation when I do recommend shared projects.
Okay.
We'll just leave that as a little teaser. That's coming shortly.
And we got one more. Does Git Trends use any caching, like in-memory caching? For example, when internet connectivity is not good. So I imagine about good offline patterns.
Yeah, of course. Let's see.
I'm gonna post a good chat or a good article about resilient network connectivity in Xamarin. I'll put that in the comments for everyone because that'll help you learn about refit and poly and Akavatch and how those things can really help you. And if Matt Sukup was here, he'd talk probably about the built-in stuff in Azure that handles offline sync for you.
Yeah, and actually, we'll be touching on poly and refit today as well. All the good things. All these little teasers. It's like we planned this.
Any other questions? We have no other questions right now. So, yay.
All right. Yeah. So just that question about caching. Yep. This is using a SQLite database, which we'll also touch on in just a minute, that stores the data every time we pull it down from GitHub. So this app just pulls all the GitHub APIs. The funny thing here is, I'll show you the secret behind it, is this is just using GitHub APIs, and all the GitHub APIs are available to anybody. And so what I did, I'm not signed in. Dang it. Well, if I was signed in, we would see a option here to look at, I think it's called Insights. And on Insights is where you can see these numbers. So like how we'll get meta with this. We'll look at the data from my Git trends repo, but all these daily views, daily clones, unique views, unique clones, all this data is just coming from the GitHub APIs, and it's available on the website, but it's buried in this Insights tab. And the reason I wanted to create this, or the reason I did create this app, was I didn't want to have to click on 100 repos every week or so, dig into their Insights tabs and figure it out. But yeah, so let's power forward. We got tons of fun stuff to talk about today. So that's just kind of the overview of how you want to architect your app. But now I want to focus specifically on Xamarin.Forms. So I think the first thing that is important to talk about is MVVM. So if you've never heard of MVVM, it stands for Model View Model. And like any architecture, maybe you've heard of MVC, Model View Controller, MVU, Model View Update. It's basically just a way to architect your app that separates concerns. So model in MVVM, let's get that, boom, model. This is essentially our POCOs, our plain old C# objects. This is just structure of our data. And I'll show you what that looks like in code in just a minute. But basically, models don't do anything. There's no logic in them. But for example, when we're pulling down data from the GitHub API is going to give me back data for like the total number of views. And that has a model, which is a list of int, probably a list of int. But that model just defines the data, the shape of the data, if you will. It doesn't actually do anything. The view is just the UI. So again, the UI doesn't do anything. It just knows, like in this case, to draw this rectangle, color the background white, add this image, add some text, but the view doesn't even know what image is going to appear here. The view doesn't know what numbers or what words for the text are going to appear. It just knows somebody's going to give me an image URL and somebody's going to give me some text. And when they do, this is where I put them. So our view is intentionally, I don't want to say dumb, but we'll say out of the loop when it comes to things like what happens when when the user does pull to refresh or anything like that. It's literally just drawing things onto a screen. And then the view model in MVVM, this is where all that logic takes place. So the model defines the shape of our data. The view describes how our UI looks. And the view model is kind of that glue holding everything together, because the view model knows how to take action. So for example, when I do that pull to refresh, it's the view model that knows, okay, I've got to go hit the GitHub APIs, and here's how I surface the data to the view so that the view can draw it on the screen. Now, the reason we recommend MVVM is, well, partly because Xamarin.Forms was literally architected around the MVVM paradigm. So it's literally the de facto architecture. I mean, you can have libraries like the reactive extensions will allow you to do things that are, we'll say, closer to MVU. Some people will claim it's not pure MVU, but there are ways to do other architectures. But the intent, the creation of Xamarin.Forms is all around the assumption that we'd be using the MVVM architecture. So let me show you what that looks like in the code. And so in my code, let's see if we can make that a little bit bigger there. So for example, what does a model look like? Well, I have a model here. This is my referring sites model. Let's make this a little bit bigger. And just you're wondering what a referring site is, the GitHub APIs will also tell you where that traffic's coming from. So in this case, this GitHub repo is getting some traffic from other GitHub repositories that are probably pointing to this repo. Somebody did a blog post that points to this repo, or just a plain old Google search that landed somebody in this repo. So that's a referring site. And let's see, this is a little complicated. Let's jump down to the base class here. Much better. So this model just has a couple properties in it. So the date time for when the data was downloaded, the name of the referrer, which would be Google or GitHub. We make sure that the referrer's URI is valid. That's what the code in this constructor is doing, just to make sure. This was something unique to the way GitHub gives me the data. Sometimes it includes the full URL, but for popular sites like Google, it just says Google. So I have to do some logic like adding .com if it's missing and making sure everything's HTTPS. And also it gives me the URI. So if we're back looking at the referring sites in this app, if I tap on, I write code sometimes, it'll take me to the URI. And that's it. But I tapped on that thing, or I tapped on that item in the list, and we navigated to its URL. But none of that logic happens in the view. This view is literally just a couple properties that declare the shape of the data. So every referring site will have these specific properties in it, and then it's up to the view model on how it handles that. Now, if we look at a view model, let's actually check out, let's hide that. Don't want to give away what that common folder is just yet. If we look at a view model, for example, that referring sites view model. So this view model is the business logic behind this page. So things like what happens when I do pull to refresh? Well, there's somewhere in here a refresh command. Whoops. Oh no, there we go. That's what I wanted. So this command executes anytime we do a pull to refresh. So if I were to put a breakpoint right here, do a pull to refresh, the debugger hits this breakpoint. So it's the view model that knows what to do anytime the user takes an action. And there's more code in here about, what do we do if the user clicks on it? It timed out because I had hit the breakpoint, and that's fine. But the view model is what handles all the logic. So it gets things like this referring site list. So that was the model we were just looking at. Again, the model doesn't do anything, but it just defines the shape of our data. And it's the view model that handles and knows what to do with that data. And what was the other thing? The view, of course. Model, view model. So the view, this might look a little funny to folks who have been doing Xamarin for a while. I create this pages folder in my app. I started this way back in the day because let's do referring sites page, because everything in Xamarin is a content page. So I was like, I'll make a folder called pages. And then later it's like, technically this is the view in MVVM. So you'll see probably most projects will call this folder views. I actually have a views folder down here, which makes it even more confusing. But these views are basically views for a specific page. So the referring sites has some specific views for it. But if we look at this, first of all, I do all my UI in C#, which has come a long way. We recently got C# markup extensions in Xamarin.Forms 4.6, which are basically extension methods that allow us to create that give us a fluent syntax for our UI. So, for example, I can create a collection view and I can say .bind, and this should look and feel familiar if you've done any work in XAML, because we're just creating bindings. We're putting things in a grid. One of the things I love about this C# markup is it allows me to define my rows by literally giving them a name. If we're working in XAML, you just have to say row 0 is auto, and row 2 has an absolute length of, in this case, whatever the shadow height is, and row I guess, no, this is row 2. There we go. See, that's why I don't like, or that's why I do like the fact that I can define them, because now I can define each row and I don't have to remember, is this row 0? I mean, it's the first row, but it's row 0 because counting starts at 0 in C#. And I would always get that confused in my head. And anytime I would create a new UI, there was always something in the wrong quadrant because of just trying to remember all that stuff. So yeah, with these markup extensions, I can just say this row is called title. This row is called title shadow. This row is called list. And then when I put things into the grid, for example, like this referring sites refresh view, I can just tell it it's going into the title shadow row. It's going to span 3 columns, or span 3 rows, and then span all the columns, which is really cool. But when we look at this, there's no logic in here. This is just drawing onto the screen. So the view just knows how to draw onto the screen. And all these bindings, you'll notice, are pointing back to that view model. So things like this refresh view, whenever it's commanded to refresh, it actually shouts out to my view model, specifically to this refresh command that exists in the view model. And so this is where we were a minute ago with the refresh command, where we set that breakpoint down here. So yeah, what ends up happening with MVVM, we have these bindings that are essentially tie our view model and our views together. So the view doesn't know what to do. All it knows to do is anytime a pull to refresh happens from the user, it just shouts out to the view model and says, hey, refresh command, execute. But that's all it knows. It doesn't know anything more than there's something called refresh command. And it's the view model that handles all that logic. So essentially, MVVM, what is it? We have a dumb UI that we call the view that doesn't know how to do anything. It just knows how to shout to its associated view model. The view model handles all the logic, and the view model can also shout back for when things are updated. So when those integer values for the total view counts get updated, the view model can shout back and say, hey, view, I've updated these. And they're always listening to each other. And when the view hears that, it goes, oh, thanks for that data. I know where to draw this on the screen. And so what this allows us to do, and the reason we recommend it, because you might be looking at this and going, gosh, that is a lot of overhead. And you're not wrong. But the benefit here is, let's say I wanted to redo this entire UI. And ironically, this was an effort that we did. A good friend of mine, Luis Pulhos, reached out to me after I initially pushed this app to the App Store, because if I'm being honest, the first version that I released to the App Store looked terrible. I'm not a designer. Everything functionally was great. There was no bugs, no crashes. So, hey, I take that as a win, but it didn't look great. And my buddy Luis, who's also a Xamarin developer in the Xamarin community, he reached out. I was like, hey, can I help you make this look like a real app should? And he was the one that came up with this layout. And what that meant was I basically selected all the code in my referring sites page and said, delete. And then using Luis's templates, we recreated it. And what's great about MVVM is I could do that. I didn't have to touch any code in my view model. So I didn't have to change anything in the logic. I just got to redraw or tell my app how to draw this new UI. And so that's the real benefit of MVVM, is we have these separations of concerns. So if we want to rip out a layer in our app, we can. If we want to change the view, if we want to do a version 2.0 update like we did with Git Trends, we can do that, and we don't have to touch any of the logic. And we know as long as we wire up those bindings in the new UI, it's just going to work, because all that view model logic is still there, and we didn't touch it. There's no risk at accidentally deleting logic code. There's no risk at accidentally adding bugs into our view model, because it had no idea that we changed the UI. And that's the point of MVVM. So MVVM gives us that flexibility. It gives us a separation of concerns. And I'll say, most importantly to me, it also helps us define where files live. And what's nice with Xamarin.Forms, essentially going with MVVM as the de facto architecture, is that I can open just about any Xamarin.Forms app. There's tons of Xamarin.Forms app open sourced on GitHub. And when I pop them open and I want to see something like, maybe there's an app that Ari made that is doing something really cool. Like he created this really cool looking UI. Well, I know when I open up Ari's app and look at the code, I just look for a folder called views, or if you're weird like me and name it pages, I can look for these folders and I can figure out pretty quickly where that code lives that Ari made and figure out what he's doing. And likewise, if maybe the app is also doing something really cool, like it's using a Azure API that I've never tried out, like Ari was talking about, online, offline sync and all that cool stuff. Well, how is he doing that? Well, I know that's could be in the view models, or maybe it's in the service layer, which we'll talk about in a second. Okay, so that's, yeah.
To add there, and thanks, this is really interesting. I see that you're talking about how you're building your UI via code instead of XAML. So could you speak a bit to the pros and cons of that, if there's a performance impact and so forth?
Oh, good question. Well, I think some context is important here. I never did any, I was never a web developer, and I never did any WinForms or WPF before I started doing Xamarin. And so when I started working at Xamarin, actually the reason why I even applied for a job at Xamarin was I knew C#. I wanted to make iOS and Android apps, but I didn't want to learn Objective-C, and I didn't want to have to spend the time to rewrite the app again in Java. So when I heard about this weird ex-Xamarin company that was on the West Coast, I was like, oh, wow, yeah, that's really cool. And the app's still totally native. Great. So when I joined Xamarin, Xamarin.Forms wasn't really a thing yet. And we did everything in C# because, well, that's kind of the value prop of Xamarin is we could do everything in C#. We never have to touch Objective-C, Swift, Java, Kotlin, etc. And so when Xamarin.Forms came out, actually, it was initially all C#, very initially, I should say. And so when I started learning Xamarin.Forms, I just kept using C#. And it ended up being, XAML has since become the more popular way to create UIs. I think probably 75% of Xamarin.Forms developers use XAML. So if you do too, you're not alone. But for me, I had never used XAML before, and I was struggling enough just to learn mobile at the time. I was still new to iOS and Android. There's 100,000 APIs that are unique to both platforms, and you have to learn the mobile lifecycle. And for me, I didn't want to add XAML to that learning curve. And so that's why I use C#. And circling back to your question, there is we'll say a slight performance benefit for doing things in C# because C#'s all ahead of time compiled, whereas XAML is just in time compiled. So what that means is when I launch a new page, so for example, I click this referring sites button, boop, that code to display this page, to run this, and the associated business logic, everything's in C#, so it's all been compiled ahead of time. If this was in XAML, the XAML parser has to first essentially transpile that XAML code into C#, and then it can generate it. So you get a little performance bump by doing everything in C#. Now, that being said, a couple years ago, we came out with the XAML compilers, or XAML-C.
Yeah.
And XAML-C helps a lot. Now, totally anecdotal, when XAML-C first came out, I was like, how good is this, right? So I made a kind of simple dummy app and did that test just like this, like tap a button that launches a new page. And without XAML-C, it took about 300 milliseconds for that page to load. When I enabled XAML-C, that dropped in half, so about 150 milliseconds. So that's totally anecdotal. That time difference is going to be different for everybody because everybody's XAML pages are different. And so more complicated UIs are going to take longer to load no matter what you're doing or whether you're doing C# or XAML. But XAML-C still doesn't compile all the XAML. It compiles a lot of it, but it doesn't cover everything. So C# will always have that performance benefit over XAML. Now, all that being said, if your app's running fine in XAML, don't turn around and change it. I mean, if there is a weird case where you're seeing performance problems and you think you can squeak out some more performance by porting it to C# from XAML, it's worth a shot. But the difference is, I won't say negligible, but I mean, we're talking in the milliseconds or in the tens of milliseconds between C# and XAML. So that is one benefit. The other things, actually, let me show you, because I did a talk recently on all this fun stuff. Let's see, where I highlighted some of them here. So XAML for C#. So that's the performance we were talking about. Refactoring and maintenance is nice because I can do things like this in C#, where if I'm in my view model and I want to change the name of this command, I can just say rename. Maybe we call it new refresh command. And then if I flip back to the sites page, because this is all type safe, it's all in C#, it's already been updated. Whereas if I did that and my UI was in XAML, then the XAML doesn't automatically get updated because XAML is essentially just a hard-coded string. So we have to remember to update all our bindings if we change any of the property names. Likewise, if you're ever jumping into a new code base, it's really nice when everything's in C# because I can say find references, and I can find out exactly where this empty data view title is being used in both my view and also on that page. So it makes it really easy to come up to speed, where if everything's in XAML, then the best way I found, and if anybody knows a better way to search XAML or to search XAML bindings, I should say, let me know. But the best way I figured out how to do it is just to literally use the search bar here. So we get a little bit refactoring, performance benefits. Then there's some silly things like I never understood this syntax, like this automation ID, just to use a constant. So like in C#, it's a string constant. So I can just say class name dot string constant name. Whereas in XAML, it's x:static. And then I have to include the namespace, but it's not even namespace dot class name. It's namespace : class name. And I don't do XAML enough to remember this. And so I hate this because I always have to Google it every time. Like, how do I make a constant in XAML?
Right.
And
then, once you learn it,
right.
To answer your question, I know ReSharper and mfractor will take care of, like, the refactor rename.
Good point.
Does work. I haven't tried it without ReSharper because I always have ReSharper installed, and I already have mfractor. So yeah, maybe I'm spoiled, but it will handle those bindings for you, and it'll even give you the IntelliSense to let you choose that stuff.
Yeah, that's a good point. Yeah, if anybody's listening and you make your UIs in XAML, make sure you're also using mfractor. I found mfractor is essentially a must-have. And yes, it costs money, but it's one of those productivity things that's just worth it. And plus, you can probably get your company to pay for it too. But the last thing here, and then we'll get back on the rails to architecture, is these converters. So creating converters in XAML is really annoying because you have to create a whole separate class. This I-value converter is not type safe, so everything's an object value, object parameter, and then you have to cast it. Hopefully you got the casting right, otherwise your app's going to crash at runtime. Whereas in C#, in our bindings, we can just say convert and then just pass in a function right here that's already type safe, because I told the button that I told the binding that this is a button and then int and bool are the two, the source and the destination. So I can have type safe bindings that I can just do in line without having to create a whole separate class, which is really nice.
And John Batchelor points out that JetBrains Writer does a great job with XAML bindings.
Nice.
Of course, JetBrains, ReSharper, same company. So Writer is very cool, and you get a lot of the ReSharper capabilities built into the IDE.
There you go, XAML fans.
Writer's not free, right? I don't think it is.
I don't know. I hear great things. I honestly haven't tried it.
Really good about it.
Yeah. I mean, my thing is mostly just I work at Microsoft, and so I try to stay on the preview / dog fooding channel of Visual Studio for Mac, because I want to try and catch all the bugs before, or help catch bugs, I should say, because I personally won't catch all of them, but before it gets to stable. So that's one of my, say, altruistic things that I try to do to help out the community. But great. All good questions.
Yeah, writer is $139.
Okay.
So there you go.
All right. So the last thing I want to touch on in Xamarin.Forms and really just in MVVM in general is I do recommend dependency injection. Now, I mentioned at the top of the show that some people are almost religious in their fervor for / against dependency injection. I used to be not against dependency injection, but service location. It was so easy that I was like, this is fine. And it wasn't until I got into unit testing, which we'll touch on a little later, that I really fell in love with dependency injection. And if you've never heard of dependency injection, or maybe you've never done it in a Xamarin.Forms app, there's actually a NuGet package made by Microsoft I'm not even using that here. I'm using AutoFac. So Microsoft also makes a dependency injection library. The one I'm using in this is AutoFac. But basically, what you do, if we look at my view model, you'll notice this constructor has tons of things being injected into it. And these are all different services. There's also, this is Xamarin Essentials interfaces, which I'll talk about a little bit later. But what dependency injection does is, instead of using static classes, we can inject that into the constructor. So any outside class that we're going to be referencing, we can pass in. And the reason this is, or one of the reasons this is nice, is we can kind of set it and forget it. So I have this dependency injection container where I just register all these types. So if any class wants to use app info implementation, or if they want to use my analytics service or background fetch service, they're all registered in this container. And what that allows me to do is main page, splash screen page. Where's a good example of where I'm grabbing that? And down here after the splash screen. Main page, repository page. There it is. So to initialize my repository page, I can just say container.resolve, and then it initializes it for me. So what's actually going on here with dependency injection is this repository page has all these dependencies, but everything was registered ahead of time. So when I say resolve, all these implementations are just added in for me. So I don't have to worry about newing up a main thread class or first run service or any of this stuff. It's all just done for me. And a big benefit is that we can do things like single instances for some of my services. So anyways, get a little bit ahead, but dependency injection is something that I've recently fell in love with. I recommend it. It is complicated though. So if you're a new developer, if you're new to C#, new to .NET, it's probably easier to stick with service location or the service locator for getting started. But for me, once I started being better about unit testing my Xamarin.Forms projects, then dependency injection became essentially a must-have tool.
I'd love to add something to that. One
Please.
thing service location and dependency injection will force you to do is thinking abstractly and coding with intent. So if anything you'll get out of it is building the interface first, figure out what's the intent of what your code should be before you think about implementation. And then you'll actually write your implementation. So as you come up with better implementations, at least your intent stays the same, because if you're doing CRUD, your C, R, U, and D really aren't going to change, but your implementation might. So your interface will have your create, read, update, and delete kind of just intent. But then you'll be able to swap that out as you get better. or as you find issues. So whether you use service location or you use dependency injection, IOC, you'll be in good shape just architecturally by starting with that pattern.
Yeah, and like I said, it is tough. It took me a couple years of doing C# before I felt comfortable with this dependency magic or dependency injection magic. But yeah, once you can kind of wrap your head around it, it is beautiful because there's even things where like if a class references a class, it references another class, references another class, it references back to the same class. Well, that's called a circular dependence. And if you try to do that with dependency injection, that dependency injection container will literally blow up and be like, whoa, nope, can't do this. And like Ari was saying, it forces you to essentially rethink how you architect and write your codes to avoid those circular dependencies. And really what that comes down to, why those are bad, is those can lead to memory leaks, and worse, well, maybe it's worse depending on your take on it, but it could also lead to what we call spaghetti code, where the code just becomes unmaintainable. So forcing yourself to think about that dependency injection architecture essentially, helps you write cleaner code. Well said.
Yep.
All right. So something else we have in our Xamarin.Forms architecture is what we call the service layer. So we mentioned earlier the view model that does all the work. Like when I click a button, it's the view model that knows what to do after the click. Or when I do a pull to refresh, it's the view model that knows how to execute that refresh. Well, if there's code that I say is agnostic to a view model, where, for example, writing code that hits the GitHub APIs. Well, I have a couple view models that all need to hit the GitHub APIs. So that's not really specific to a view model. Then we can put that in what's called a service layer. And the benefit there is, well, there's a couple benefits. The one big one being that separation of concerns. So that single responsibility principle, where each class is responsible for essentially one thing. So I have a class that's responsible for interacting with the GitHub APIs. And I can now share that class between multiple view models. I don't have to rewrite any code. And so to kind of simplify this a little bit, one of the ways I think of, like when I think of, should this go in the service layer? I ask myself, will I be using this in other view models? Will multiple view models need to use this code? Then I break it out and I put it in the service layer. And so what that looks like in Git Trends is I have a folder called services. So again, these are all things that are agnostic to specific pages. So like I use App Center to do to track crashes and get crash reports and timing things. I use, like we mentioned, the GitHub APIs, and this is all code that accesses the GitHub APIs. So it's very easy to know which or find those services, because if I want to access the GitHub APIs, I can scan through my services folder, and then here's the V3 APIs, the GraphQL APIs for GitHub, and I can quickly figure it out what I need to reference. And if I didn't have them in the services layer, then I would essentially be duplicating this code across multiple view models. And so that's always my trigger, is if I find myself duplicating code between view models, break it out, put it into my service layer. And something I try to do, well, I do is all of my services, they're all, we'll say single instances, because that's what it says here. But basically, for all intents and purposes, these are singletons. And the dependency injection container takes care of all this for me, which is great. But what's nice is when I have two view models that need to use the GitHub API v3 service, well, I don't need two separate instances of these, because my services don't maintain any state. There's nothing in the service that is specific to things like, the app went away. But is the view refreshing? Is the view busy? All that's handled by the view model. These are all stateless that just know how to hit an API and get data back, or do some image caching or translate languages, since Git Trends handles a couple different languages like Spanish and Dutch and Portuguese. Shout out to the community. They added all these awesome languages for me. Since the app's open source, I just got all these awesome pull requests that were like, hey, I speak Spanish. Wouldn't it be cool if we had Spanish language support? I was like, yeah, that's awesome. I don't. Do you mind opening a pull request? So we are still looking for Chinese. If you know anybody that speaks Chinese, send it my way, because I have a lot of Chinese users for Git Trends, but we don't have a Chinese translation yet. So but anyways, yeah, services, they are essentially view model agnostic. They can be used by multiple view models. I recommend keeping them stateless so they can stay as singletons, so we don't have to create a new instance every time we want to, say, pull something from a GitHub API. But one of the things we mentioned at the top of the show as a little teaser is Poly and Refit. These are two must-have libraries. If you've never heard of them, Poly allows us to do automatic retries and exception handling. So when you think about resiliency, like we were talking about earlier, if, let's say, well, before COVID, let's say I'm on the bus and the bus is switching cell phone towers or it's going through tunnels. Well, the user might lose that internet connection briefly, which would cause that API request to fail. Well, with Poly, I can tell it to automatically retry. And so when that happens, my code automatically hits the API again. And you can set how many retries you want. I think my default is 3. You can set things like how long to wait between retries, because you don't want to retry right away, because computers operate in the nanosecond scale, the millisecond scale. So if I couldn't connect to the cell phone tower a millisecond ago, there's a likely chance that I won't be able to connect to it again right now. And so just to show you what that looks like in the code.
And we do have a question.
Oh, yeah, shoot.
So Mark is asking, is the view model responsible for getting and or storing the data that is in the model and shown in the view? Or is that the model's responsibility?
You were exactly right in the first part. The view model is responsible for getting the data, and then essentially it jams that data into a model, and the view knows what to expect from that model. So they all kind of work seamlessly together, but yeah, it's all up to the view model to do the heavy lifting. The model's just kind of hanging out and going, hey, here's what the data needs to look like. Let me know when you got it and when you're ready for me. So here's an example in code of what Poly looks like. This is a method I wrote called attempt and retry, where, kind of like it sounds, it'll wait and retry automatically. So I use this for all my API calls. Like if I jump back to, so like this API service will always call attempt and retry when I want to get, for example, the repository view statistics. And so what's nice is I tell Poly the number of retries. I set my default to 3. And because we don't want it to retry right away, because again, if we couldn't connect to the internet a millisecond ago, probably won't be able to connect to it now a millisecond later. And what I do is what's called an exponential backoff. So I tell it it passes in the number of retries, but it'll wait 2 to the power of the number of retries. So this code is basically just doing 2 to the power of n. So this means the first retry will wait 2 seconds between when that API call failed to when it tries again, because that's 2 to the 1. The second time, it's 2 to the 2 squared. So that's 4. So it'll wait 4 seconds. And then the last time will be 8 seconds in between. And so hopefully 8 seconds, if 8 seconds have gone by, the user's reconnected to a cell phone tower. And if not, then we know for sure that their internet connection is dead. The other nice thing with Poly is we can tell it which exceptions to handle and which ones not to. So I created this little local function that checks to see if this API exception is forbidden or unauthorized, because if I try to connect it to GitHub APIs and maybe my token's expired, well, I'm not going to retry that because the token's expired. So there's no point in retrying, because I already know that this has failed because of well, not necessarily because of the user, but because of something on the user side or the client side. So yeah, I just checked to see if it was forbidden, if it was unauthorized, then I don't retry. And then all the other ones, yeah, retry. So if there was a timeout exception or something like that. And what's nice is I now have this static method that I can just leverage for all my APIs like this, where I just say attempt and retry, and Poly will handle all of that for me. So huge fan of Poly. And the other one I recommended here is Refit. Refit. Oh my gosh. I don't, I laugh when I think about life before I found Refit, because Refit, if you have to access APIs, let's see, there we go. So Refit lets us define our APIs the same way. If you've ever done anything in ASP.NET Core, if you created an API or controller in ASP.NET Core or ASP.NET Framework, you're familiar with this attribute syntax. And so all I have to do is tell Refit to say, if I want to get the repository view statistics, well, here's the API I want to hit. I've already told it the base URL, by the way. So it knows the GitHub API / repos owner. And actually, you'll notice owner and repo are in brackets. Well, that's because I need the user to pass those in. And so this is it. This one line of code I can call from my app just like this. And it knows to make a GET request to that GitHub API. So before this, I had a base class that was kind of generic and static, and I would just copy paste that everywhere for doing Git APIs in C#. Once I found Refit, I just deleted that because I can just easily define my API endpoints like this. So huge fan of Refit here. You can pass in headers. You can do things like, you can even pass in headers at runtime. All sorts of cool tricks you can do with Refit, and it'll save you tons and tons of time trying to manually write that code. Ooh, all right. Hey, Ari, I noticed we have about 8 minutes before the top of the hour. Is it cool if we keep going a little longer?
I think it's okay. I mean, we're recording the whole thing. Heads up, okay. The Refit stuff, and we got a question come in. Does it? Oh, that's a good question. ASP.NET nerd. I don't. Sorry, ASP.NET nerd. I'm gonna call you ASP nerd. I don't know how to. Maybe his name isn't ASP.NET. Maybe it's not ASP nerd. I keep wanting to say ASP.NET. Dang it.
What's the question?
He said, "How does Refit handle connections? Does it make and reuse one client per base URL?"
Ooh, yeah, you nailed it. If I zoom out. So I have this GitHub API client, which is defined up here. So this is that interface, that Refit interface. And yeah, every action that's taken using this client will reuse the same HTTP client with the same base URL. And let's see, where do I define this? Oh, I did it in my container. So I have some code here that creates HTTP client, but that client gets passed in. You just say REST service.for, that's the Refit API we were just looking at. And then you pass in your HTTP client, and that's where I pass in my GitHub API URL. But yeah, no, you nailed it. We give it base URL, and it'll reuse HTTP client, because if anybody's listening and you are disposing of HTTP client, don't. HTTP client is meant to be reused. Never dispose of it. There's whole things with sockets, but we'll say, trust me, reuse your HTTP client.
And that's because it's a reentrant object. That's the key. And I'll post that link, HTTP client as reentrant. If you're using a using around it, you've been using it wrong, which I didn't know until a couple years ago when I read about it.
Same.
I also put the links to the resilient network handling or resilient network connections in Xamarin. Those are on the Indy Xamarin Meetup page, because for whatever reason, YouTube wouldn't let us put the links to those in the chat. So it's there. But you can also just search for resilient network connections in Xamarin. There's great articles that talk about how to effectively use refit and poly and even Akavatch for caching your stuff.
Yeah.
And on the MVVM stuff, I did put a link in the chat about the Microsoft Learn article that covers how to create MVVM models, and it walks you through that whole thing. It's like a 25-minute lesson.
Awesome. All right, and rounding out our Xamarin.Forms architecture, if you do want to have local caching or you want to store data locally, well, then you got to have a database. And so I wanted to bring this up because SQL, there's a library SQLite-net. If you've been doing, let's show this. This is just a NuGet package. So git trends, NuGet package. Where are you? Whoops. SQLite-net -PCL. Ignore PCL. That was what it was originally named like 10 years ago when Frank Kruger made it. But this is going to be the most performant database that you can add. The reason I say that is it doesn't have all the bells and whistles of something like Entity Framework. But as of today, don't use Entity Framework in your Xamarin apps. There's known issues with Entity Framework. The team's aware of them. I've been working with the team, and Matt Sokup has also been working with the team internally to help pin those down. But there's, we'll say, use cases where things like just initializing the database connection on Entity Framework in a Xamarin app takes 3 seconds. And if you are pulling data from your database when the app launches, well, that means your app launch is going to be delayed by 3 seconds, which is a lifetime in mobile. We want our apps up and running and being used by the user within 3 seconds. And so try to avoid Entity Framework Core for now. The team is aware of those. There's a GitHub issue. If you Google it, you can find it. But this is the one I recommend, SQLite-net -PCL. It doesn't have all the bells and whistles, but it's going to be the fastest one for you. And to show you this database layer, let me show you this base database first, because I want to point out I'm using Poly again. Now, specifically, I'm catching these SQLite exceptions. But what I recommend is to use SQLite when you initialize it. There are things like enabling write-ahead logging, which will give you a little bit of boost in performance. And so we won't dive too deep into the databases, but I did want to recommend SQLite-net. And also, when you do things, make sure to include Poly, because what I found is sometimes with when you're saving stuff to a database, we're doing multi-threaded things, but if you're trying to write to the database at the same time, sometimes you'll get these SQLite exceptions where things time out. And so if we just do things, where's my reference? This should have done it like this. Find references. Oh, there we go. So anytime we're doing things with a database, I put it in this attempt and retry. Now, the biggest difference here with this Poly retry is the number of retries. I crank it up to 12, and I do the same exponential back off, but at the millisecond scale. So the first time I'll wait 2 milliseconds, then so on and so forth, because milliseconds is like a lifetime when it comes to CPUs and databases. So that's a little different than when we're hitting APIs. All right, on to testing. Now, there's 2 kinds of testing for our Xamarin apps. There is UI testing, which we'll talk about first. Next up, we'll talk about unit. But UI testing emulates a user using your app. So users can tap buttons on the screen. They can pull to refresh. They can enter text into text boxes. They can navigate to and from pages.
Sorry to interrupt. There's a question.
Sure.
What about Dapper?
No clue. I've never used it.
Oh, so Dapper is like a very light ORM. So
yes, that's right.
And I don't know that it wouldn't work, Elahi. I don't know if I'm saying that right. I haven't tried it, but it might work. I don't know why it wouldn't, because it seems to work with .NET Standard. Yeah. Another thing you can look at is also Akavach, which is a whole caching framework. Akavach, there we go. And it'll let you manage the lifetime of any cached object. It's pretty cool. It's in that same link that .NET Foundation posted above about resilient networking in Xamarin.
Right on. Yeah, no, good question. That's right. I remember Dapper now. Yeah, I'm unsure of how its performance does on Xamarin, but if it's something where you try it out and it works, great, go for it. But if you notice things like we've been seeing with Entity Framework Core, where there's things like 3 seconds to do a database connection or a couple seconds to do a database migration, those are essentially showstoppers for me, which, again, the team's aware of it. We're looking into it. Hopefully someday we'll be able to do everything in Entity Framework Core, because it's great for backend databases that live on servers, really powerful servers that are always turned on. But mobile is this kind of unique, weird edge case that you have to make sure you plan ahead for it. So circling back to testing. UI testing emulates a user, and the way this works in Xamarin.Forms is Xamarin.Forms has every UI element in Xamarin.Forms. So a button, a view, a label, content page, anything that exists in Xamarin.Forms has a property called automation ID. And so what I like to do here, and this is where Ario is saying there are places where I do recommend a shared project. This is one of those places, because what we want to do with our UI tests is we want to use automation IDs for everything. Let me show you what this looks like real quick. Let's jump over to we'll do a find reference. So things like this close button is being used on my referring sites page. Oh, that's the UI test code. There we go. So when I create this close button, I tell it to use this automation ID. And this is my Xamarin.Forms code. Now, in my UI test code, which is the one I opened first, jump back to that, we can reference that same ID. Automation IDs are just string constants, and it's essentially a unique identifier that we can use for our tests. So this close button is using that same string constant close button that we're using in our Xamarin.Forms code. So the reason, the reason I recommend having a shared project is, the reason I recommend sharing that code first is so that you can have these public string constants that are shared by both Xamarin.Forms and the UI tests. I learned this the hard way because I used to just hard code the strings and I kept having typos. So my UI test would fail because I couldn't find the button, but it's because I spelled the word close button wrong in my testing code. So by having a constant string that's shared between these Xamarin.Forms project and my UI test project, I don't have to worry about typos anymore. And what these UI tests look like, if I want to say things like tap this store rating request button, you just say app.tap. We pass in that button that we initialized that uses the same constant. The UI test will scan what's visible on the screen for that string constant. And if it finds it, it'll tap it. If it doesn't, my test fails. So the reason I recommend using a shared project here is going back to the fact that .NET standard libraries generate a DLL. If what we're doing by using a shared project is just speeding up our compilation time. So there's two things going on here. I don't want my UI test to reference my Xamarin.Forms project because, A, it doesn't have to, and B, it's going to take forever to compile because when you click compile, it first compiles all the references. So if my UI test project was first referencing my Xamarin.Forms project, it's got to build this whole .NET standard library and its DLL, and then it can build its own DLL and then run the UI tests, which can get a little painful. So having a slimmed down separate project essentially for these constant strings makes everything really, really fast. And the fact that it's a shared project, we get away from the overhead of having to first generate the DLL, then compile the head project. So this is one place where we're just using string constants. Unlikely that you'll shoot yourself in the foot, and we can get a little bit of performance benefit. Now, the ironic thing is my Git Trends app is actually using .NET Standard. Basically, I'm sharing a bunch of data in this mobile common project. So these are all my automation IDs, but all those translations, all these resx files also are shared so that I can run my UI tests and I can test out the app in Spanish and I can test out the app in German. And the only way to do that is to share all the information between the Xamarin.Forms project and my UI test project. But resx files just don't work in shared projects. There's a lot of code generation that happens in the background by Visual Studio, and that just, for whatever reason, isn't supported in shared projects. So I had to use a .NET Standard library here. So I'm being a little bit hypocritical, but that's okay, because using resx files, so that's my excuse anyways. And then there's also things like we can share certain services like this mobile sorting service. So like the app closed out, but we can sort by views, we can sort by clones, we can sort by stars, and all that logic I want to be able to verify in my tests. So I put it in my mobile common project. So my UI tests, my unit tests can also verify that as well. And there's also some models here. UI tests have these cool things called backdoor methods, where you can literally enter into the back door of the mobile app. So instead of just tapping things on the screen, if you want to confirm what's in the list, you can write some backdoor logic into your Android app, into your iOS app. And when you do that, it has to pass back a model. And so it's easier just to share those models between, so that we don't have to essentially rewrite the same code.
All right, we have a question. ASP Nerd asks, I don't recall if you covered this or not, but are there good resources for already made styles or style sheets for branding and nicely formatted app parts like the list your friend helped you redo?
I can't think of any off the top of my head. Actually, what do you do, Ari? Because I'm not good with UIs. And so
I know that so if you haven't seen it, go check out Syncfusion. They have a whole set of libraries, and as long as your app makes less than $1 million a year, it's free. So that's kind of cool. I didn't know that, which is why I wasn't using their stuff, but they're free. I believe Telerik and Infragistics also have ready-made templates. I know there's a number of sites out there. There was even like a Xamarin gallery at one point. I don't have the link to it. Let me see if I can find it. Yeah, was it the Xamarin.Forms? There's a really cool like Xamarin.Forms like control gallery at one point that was really, I don't know where it is. At one point, I don't know where it is. Anyway, it's somewhere on the internet. At one point, I had it linked. But yeah, Syncfusion, Infragistics, Telerik, they've got that stuff. Syncfusion's free, and I'll see if I can look that stuff up. The other thing is as you build components in your apps that you like, because you'll be like, wow, I worked really hard on that. You can extract that relatively easily into a reusable view. So try to build your libraries of those reusable views. Like if you go the XAML route, because I'm a XAML guy, I find it very easy to have those reusable components, and then I just inject them in the XAML, and then I can just swap it out, as I see fit, or reuse it all over my application like a header. Very common. Another one to take a look at, go take a look at Sharknado.
Oh, yes.
I keep Sharpnado. I'll write these down real quick so people won't forget. So Sharpnado is one. There's like a Sharpnado UI. I know Matt and James were talking about some of the cool stuff it's got with like the blur background effects and everything. That's really neat. There you go. Yeah, material frame.
Yeah. I just think what's really ironic is I'm literally using those in this app and blanked on it. Like this chart is all Syncfusion. I didn't write any code for this. I just use a Syncfusion library, which is very convenient.
Sweet. Let me write down the other one. Someone was sending me a Teams message. Also, Progress, or pardon me, Telerik has stuff and logistics. Syncfusion is free, Balahi, as long as your app makes less than $1 million. So if it makes $1 million or more, then hopefully that means you can afford it. But it really is free. You'll see. Just I can walk you through it. If you ever have a question, just ping me. I'm at RE on Twitter. But yeah, it is free. Let's see what else. Are there any other questions? How does MVVM work if you want to display more than one record from your database on the screen? Doesn't model only describe the data types of one record? I can answer that one, but I'll let you do it.
Sure. Hopefully we're on the same page. All right. But I was going to say, if your view model just has a list of that model, I mean, I do this for all the lists in this app. Like each of these, the data that appears in each of these rows is a repository model, and that contains the data for the name of the repository, the avatar URL, the numbers for views and stars. And so, yeah, you just put it into a list, and then you can use MVVM to essentially extrapolate that view for each row, and it'll populate in our list like this. Is that what you were thinking too?
I wasn't listening. I was looking something up.
So yes, I nailed it.
I really once you have data. So if you have your view model, once you've got your data, you can display anything you want the way you want to. You're not bound to a particular data type. You can make things as complicated or as simple as you like. That's really up to you. The view model will hold on to that data, and it will handle the actions you want to take on it. But how you present it, that's up to you. That's actually not the view model's job. The view would do that sort of work.
So yeah, short answer, yes.
I just posted something about visual, so visual material. That may help. That's another cool thing that's out there, and I'm trying to find. Here's the Xamarin UI kit templates from Syncfusion. All right, I can do this without.
Nice. No problem.
I'm all excited. It's so neat. I remember when none of this was free, and it was all really expensive, and now it's like, ooh, yay.
Yeah, the ecosystem's pretty amazing. I will say, just a general recommendation. If you are about to do something, Google it first to see if it already exists. Like this, so Sharpnado, this material frame, this is Sharpnado material frame. And you can do cool things like that has this little bit of elevation, so it looks like it's popping out of the screen. And I do things like, if it's disabled, the elevation will go away, so it almost shrinks back into the screen. So it's subtle, but you can see that elevation isn't there compared to these other ones. So yeah, just super cool things. And this is like a couple lines of code, because who makes Sharknado? Jean-Marie did all the heavy lifting for us, and he's way better at it than I am. So yeah, definitely just do a quick search to see, like, maybe there's like a shadow button that somebody's already made that we can leverage. All right, so circling back to the architecture, next up is unit testing. Your unit test has to reference your, in this case, Xamarin.Forms project, because that's where your services live, that's where your view models live, that's where your database lives. And the rule of thumb with unit testing is have a test for every service, have a test for every view model, and probably more specifically, I should say every public API, because each service class will have protected and private methods. And a common question you get is, well, how do we test those? Well, you don't. I mean, there are ways to do it that I don't recommend. You can use reflection to access private methods, but then you're kind of breaking the whole point of C#, in my opinion. And so, yeah, test every public API. Those public APIs will reference those private methods. And so you can still get to them, and you just have to make sure you have a test that covers those paths. And so what this looks like in Git trends, let's go ahead and shrink that down a little bit. So my unit test, all these tests, you can see I have, here's all my tests for all my services, all my tests for all my view models. I even I have this test to make sure we have resx. So if you send somebody who knows Chinese my way to Git trends, we can add that in here, and the resx test, make sure that all the resx is valid. And so these are lifesavers. For Git trends, this is a free app. I don't make and haven't made any money off of it. And I won't say the only developer working on it, because I've had amazing help from folks in the community, but probably 98% of the code I write and maintain. So this is just something I do for fun on nights and weekends. I made this as a tool to help me because I saw the need and love that other folks are using it all around the world. But the only way I can survive as an individual developer, an indie dev on a free app, is by having all these unit tests. So things like, all these APIs. So testing things like making API requests for valid repos, making API requests when it's unauthenticated, making API requests for invalid repos. Having all these things here allow me to add new features, and then I can quickly run my suite of unit tests, same with my suite of UI tests, and know that I didn't break anything. And then, of course, every time you add something new, add a new unit test for it. And this is really where dependency injection comes into play, because specifically with Xamarin Essentials, if you try to use certain Xamarin Essentials libraries in your unit tests, it just blows up. There's certain Xamarin Essentials APIs that just don't account for .NET Core, which is, I'm using this unit test library as a .NET Core library. And so they just don't work. And so the only way around this is to essentially mock them out. So basically creating this folder for mock services. So things like the browser. Well, .NET Core doesn't have a browser, but Xamarin Essentials does. And so if I have code in my service layer, my view model layer, that opens up a browser, and I try to unit test that, it's going to blow up. It's going to fail. Not because my code is bad, but because there's just no implementation for a browser. So there's this amazing library, Xamarin Essentials interfaces, that's made by my good friend Ryan Davis. And he essentially takes every version of Xamarin Essentials and then creates an interface around it. So this iBrowser is an interface that we can use to essentially create a mock browser implementation. And all of this allows us to do things like, well, coupled with dependency injection, now, there they are. So I can create all these mocks. So or analytics service, right? Like this is App Center. App Center doesn't have a thing for .NET Core because it's made for iOS and Android. And then all these Xamarin Essentials interfaces that I can mock out. And what this ends up looking like is back in that Xamarin.Forms source code for things like I do some background fetch, I can tell Xamarin.Forms dependency injection that I'm just going to pass in an IApp info, which in the Xamarin.Forms dependency injection, this will inject into it the Xamarin Essentials IApp info. But in my unit testing, it's going to inject in a mock app info that I created. So this is where dependency injection really became critical for me, was when I started to essentially up-leveled to making sure I unit tested everything like a good, responsible developer, which, I mean, really, it's only my App Store apps have unit tests. I have a lot of just playground open source projects that I don't, probably should, but Yeah, if I'm going to push it to the App Store, it's got to have a suite of tests because I'm the only developer working on it. And I need to make sure I don't break anything, or if anybody from the community opens up a pull request, that they didn't accidentally introduce any new bugs. So highly recommend Xamarin Essentials interfaces. It's just a NuGet package. But yeah, when you're doing unit testing, this is really where dependency injection for me, became critical. Whew. All right, we're almost there. A couple more slides, because the next thing that we want to talk about is including our backend, because Xamarin.Forms is all done in C#. Our unit tests are all in C#. Our UI tests are all in C#. And our backend is also all in C#. So we can create APIs, we can create Azure functions, and because everything's written in C#, we can share code. And this becomes really critical when we talk about making our own set of APIs, because our APIs will expect a certain model, and our Xamarin.Forms app will also expect a certain model. And so instead of duplicating code, we can put these into a common folder. And so this is another place where I recommend using a shared library, because this code should all be, we'll say, application or platform agnostic, because we're just talking about some models, some interfaces. Nothing in here should be anything where we rely on a specific framework. So we can use a shared project. And again, that makes sure we don't create a DLL every time. We can take advantage of that compiling performance benefit. But again, if you're uncomfortable with shared projects or you're not familiar with them, .NET Standard is still totally cool. And what this looks like in Git Trends is this little folder right here. So things like refit. So I have Azure Functions. If you never heard of Azure Functions, it is Azure's serverless implementation. So functions are really cool because they're basically just a method that runs in the cloud. It's serverless, so it only, when it's not needed, it scales all the way down to 0, which means that, yes, this is in Azure. Yes, you have to pay for Azure, but with serverless Azure Functions, I've never had a bill higher than 10 cents a month. So 10 US pennies, I can run this code in the cloud because it only runs on demand. So certain things like creating that login token needs to be done in my Azure function, but that's also code I'm leveraging in my mobile app. So I can share that code, even though, yes, it's a service. And so I have all the refit implementations, any models that I'm passing back and forth, like specifically these DTOs. So like we are passing back this generate token DTO. So this is what has to be generated on the server side, but it's also what's going to be received on the client side. And so instead of duplicating that code and making sure, well, duplicating code is always bad, because if we update something on the server side, then we have to remember to update on the client side. Instead, we can just share that as a model between the two. So anything we want to share between our cloud backend and our mobile app, we can put in this shared folder here. And then also things like constants, like the GitHub APIs, the OAuth scopes that Git Trends needs. All this stuff can be stored here. And then that way, we can share it between our servers, our APIs, our Azure functions on the back end with the mobile app. And this really, to me, is the biggest benefit when it comes to being a C# developer, because yeah, there's technically Swift servers and Kotlin servers, but they aren't very popular. I can't speak to whether their performance or anything because I haven't used them, but that's not usually the go-to when you're creating backends. You don't usually say, "Oh, I'll make this backend in Swift." But with C#, we have very robust tools like ASP.NET Core and Azure Functions and all these great things that we can leverage, and it's all in .NET. So it's in .NET. We can share code, and that way we don't have to worry about maintaining server-side code versus client-side code. We can share that code between.
Yay, sharing code. Woo! We did it. Yeah, that's why we use Xamarin anyway. Hey, I did have a question from John Batchelor.
Hey, John.
So James was saying there were reasons not to have interfaces within Xamarin Essentials. Any idea what that reason could be? And thank goodness for
Yeah, thank goodness for Ryan Davis and Xamarin Essentials interfaces. I don't know. My hunch is that, well, we'll say here was my experience. I agreed with James until I needed to do unit testing, because until then, all my Xamarin Essentials code was running on a Xamarin app. So yeah, the browser implementation worked every time because Xamarin Essentials has that implemented for iOS and Android, and great. And so, yeah, I'm not sure if it's just a thing where they haven't felt the pain of writing a unit test, but one of the other things that is, we'll say, a common thread within, say, the .NET world is when a good open source library is created, we don't want to overtake that. Is that's kind of like an but basically, yeah, we don't want to step on anybody's toes. And Ryan made this library. He should and does get all the credit for doing it. And so that's been a trend I've noticed where folks will ask that for other Xamarin Essentials things as well. Like, hey, can we bring this in? And the initial answer is typically, well, it already exists. And this already works great. And so, yes, we could implement it. We could roll it in. We'd have to tweak it to fit into Xamarin Essentials. But for now, yeah, just use this other library. So, yeah, I don't know. I don't know if it's maybe something we could get on the roadmap, but yeah, I wish I had an answer because I wonder the same thing. I wish it was in there. I know the original design decision was to keep it simple, which is why everything was just static. So you didn't have to create instances. You didn't have to worry about doing that. So the simplicity is there, but I say, why not both? Good question, though. Okay, so we are way over time, but let's round it out with what is coming down the pike.
We have one more question.
Oh, sure.
Let's see. Can you show some code where one of these IDs is defined?
Is that a automation ID?
Let's talk. I think that's the automation ID. Let's answer that one after the future architectures so people can see the rest of your presentation.
Sure.
If you don't mind, Mark, on that one.
No problem. That'll be a quick answer too. So yeah, last but not least, like what's next, right? We Ari and I were chatting about .NET Maui coming, and yes, it is coming. It'll be in .NET 6. .NET 6, the first release, so the very alpha preview of .NET 6 should be available to everyone in November 2020. So we're only a couple months away from at least seeing the alphabets. But I personally won't be porting my apps to .NET Maui until we get at least a release candidate out, because the initial preview releases, those APIs are subject to change. So I'm being selfish here, but I personally don't want to have to port my app to an alpha version of .NET Maui and then have to report it again if the APIs happen to change. But with .NET Maui, our architectures are going to look very, very, very different. There's a lot of things we have to do as Xamarin developers today that are just a construct of how .NET works. So things like, if we're in our Xamarin.Forms project and we need to access an API that exists in our iOS project, we have to do things like either dependency injection, service locator, to do what's called inversion of control and get back into the parent project. And that's not easy. Like when I was first learning Xamarin, that took me a while to wrap my head around. And I imagine it's true for other new developers. And so what we're doing with .NET Maui is we will be marching towards this world of what's called a single multi-targeted project. Now, multi-targeting is a thing. It's been around for a couple years, but it's mostly used in libraries. So actually, speaking of Xamarin Essentials, Xamarin Essentials GitHub, if we check out the Xamarin Essentials source code, Xamarin Essentials is using a multi-targeted library. And so if we look at things like, if we talk about the browser, let's check it out. So you'll notice there's all these things like browser.android.cs, browser.ios.cs, and then there's also browser.shared.cs. So the way multi-targeted projects work is, if I zoom out and look at the CS proj, what we do, we say target frameworks, and then we include the frameworks we want to target. So .NET Standard, Xamarin iOS, tvOS, Android, the different flavors of Android, ties in Xamarin Mac. So all of these frameworks are targeted in this one project. And your next question is probably, well, hang on. There's no way you can do that because you're going to blow up the compiler, because there's APIs that exist in Android that don't exist in iOS. And you're right. So the way we handle that is by using the file names. So browser.android.cs will only compile when we are compiling for Android. Likewise, browser.ios.cs will only compile when we compile the iOS project. And obviously shared is the one that gets compiled for all of them. And then there's also .NET Standard. But anyways, if we look at the shared code, this is using partial classes. So this is the world of single multi-targeted projects. Is everything's a partial class. So this shared file has the generic API layer, right? So like OpenAsync, this is the one we call from our Xamarin.Forms apps. When we're using Xamarin Essentials, I say, oh, wait, OpenAsync, and I pass in a URL. And then they're doing something under the hood. They're calling a different method. We're just calling a different method. And what we'll notice is there's a lot of methods missing from here. And that's because those methods live in the platform-specific implementation. So by using partial classes, we can have our shared code and our platform-specific code in the same project. And then instead of having all these different projects and using a version of control to get back into the platform-specific APIs, we can just rely on the compiler to know, oh, hey, I'm compiling for iOS. Let's make sure to include browser.ios.cs. And so that's where we can call platform OpenAsync. And this has all the SF Safari view controllers, all the platform-specific APIs for iOS can go in this file. And we don't have to do any IOC craziness. So the future in .NET Maui will be to leverage these multi-targeted projects. And the difference here is Xamarin Essentials can do this right now because it's just a NuGet package. It doesn't have to worry about including a runtime. If you make a NuGet package, you should be using multi-targeted projects. Well, let me rephrase it. I highly recommend it. I say should be using because literally 5 days ago, I just ported my NuGet package called Async Await Best Practices over to single multi-targeted project. But multi-targeted project has been around for about 2 years now. So it only took me 2 years to catch up. Don't feel bad if you haven't yet either. But for libraries, yeah, multi-targeted all the way because it makes your code a lot easier to write and maintain. You don't have to worry about inversion of control. But what we don't have yet, and what is coming in .NET 6 and .NET Maui, is the ability to do this with runtime. So libraries, you can do that today. If you're creating a NuGet package, multi-targeted project, awesome. .NET Maui, we can now expand this to things like here in this screenshot, we see, well, first of all, we just see one project. There's not myapp.ios. There's not myapp.android. There's not myapp.uwp. There's just myapp. And if we want to access those platform-specific APIs, we just create a file called bluetoothadapter.android.cs. And we can do whatever we want with the Android APIs. If we want to hit iOS APIs, bluetoothadapter.ios.cs. And we can do whatever we want. And that way we can just use partial classes and this secret sauce in the compiler with file naming to access all the platform specific APIs for us. So the other cool things that we're working on is being able to share fonts. Font embedding is actually already a thing in Xamarin.Forms. Like I'm doing that in Git Trends. I have fonts in my Xamarin.Forms project here. Resources, fonts. So I have all my fonts here. And then I just have some assembly attributes to say, export this font. And I give it a name so I can reference it elsewhere in my Xamarin.Forms code. But this way, I don't have to add each TTF, OTF file to my iOS project and my Android project and make custom renderers for it like we used to have to do. Now I can just use this assembly attribute. And then in like my splash screen page, for example, I can just say font family, Roboto bold. So multi-targeted projects are the future. And what that entails is a partial class for, it's not shown here, but well, we can go back to essentials. So a partial class for, yeah, we can do this even better. Show them side by side. You go there, boop, boop. So public static partial class browser, public static partial class browser. And these two can just reference each other as much as they want. It just happens to be that this one is our iOS specific APIs. And this one is our shared APIs, so non-platform specific. And this is how we will be able to take advantage of multi-targeted projects in .NET Maui. I'm really looking forward to this. But we won't be able to play around with this for another couple months. So one of my plans is when .NET Maui comes out in November and we get our first peek at it, I'll probably take a simple sample app or dummy app that I've made in the past that is not in the App Store, and then try to port that over using these partial classes and the file extensions just to get a feel for this partial class. Because I don't know about you, but I never used partial classes. I always thought, like, I knew they existed, and I know that's how XAML works with it takes advantage of partial classes, and I knew that, but like I never saw the need to create a partial class myself. But now I see the light. Like having partial classes and compiler specific file extensions or platform specific file extensions for the compiler. This is just going to be a beautiful world. You know, imagine having somebody new join your Xamarin development team. They've never done .NET before. You don't have to teach them about inversion control. You don't have to teach them how to access platform-specific APIs, because it's as easy as just naming your file with .ios.cs and making it a partial class. Whew. Okay, that's it, Ari. That's all I had lined up. Do we have any questions about this?
A lot of information. So we have a couple questions. The first one, let's see. Can you share some code where one of these IDs is defined? So I think that's
yep. We got to circle back to that. Yep. So these are just, and we're also assuming you're talking about, or the question is asking about automation IDs. So if that's the case, great, because that's what I'm about to show you. If not, feel free to make another comment to correct us. But for example, let's see, I had that referring sites page. So it's literally just a public constant string. You can name it whatever you want. I could have named it apple tree. Wouldn't make any sense, but because this constant just needs to be the same, let me rephrase that. It needs to be a unique identifier, and it needs to be the same reference in my Xamarin.Forms app as my UI test app. It can be whatever, but obviously apple tree wouldn't make sense here. So what I do, I'm kind of lazy, and I'm also bad at thinking of names. So to keep it unique, I just say name of and reference the actual constant and the class that it lives in. And I do this. I have tons of tabs open. Let's do this. Don't save anything, because I'll show you one side by side. Like the repository page also has a collection view. So since these both have collection views in them, to keep them unique, that's why I use the name of the class it resides in, plus the name of the automation ID. And so when I reference repository page automation IDs.collection view, my UI test knows to look for this string that is repository page automation IDs collection view. So this is just the way I do it. Like I said, you could always just do collection view 1, 2, 3, and that's fine. It just has to be unique. I guess you could also don't do a GUID. I'm not going to go there. Do a hard-coded string or leverage name of if you want to as well.
That's what the GUID stands for.
What's that?
I was making a joke. Every time I see something in code that says, I don't know, whatever, there's not even a variable name, but just a GUID is in there, and no one knows what it means. Like, GUID come from? What does it stand for? Well, didn't you know?
GUID.
That's our application ID in Azure, Azure AD. Well, set a variable name for that. So we had a question. If you have an external set of APIs that you manage, what is your method of authentication from the mobile app into that? And how do you handle new users, etc.?
Oh, that's a whole other meetup. So
ASP nerd, and I also pointed him to the Xamarin Essentials Web Authenticator, because Azure AD, there's a whole authentication system for that. And another thing that you might want to take a look at, ASP nerd, is Azure's API management. And Azure has, or probably Amazon, AWS has this as well. They'll actually take any number of APIs that you've got, and it'll abstract them, put them behind a single set of security. So you can control the flow from different callers with different security, all in a UI. So you can take a bunch of UIs and put them behind one API management structure.
Yeah, I'll show you.
He added a follow-up question for that, I think. If you have your own managed API, how do you handle your mobile app connecting to it for security? And how do you handle users in your app?
Yeah. So we'll break this into a couple parts. So if you're using Azure actually makes it pretty easy to implement authentication. I just want to show you this. Like I was telling Ari, I created my first website just this week. Like I said, I never was a web developer before getting into mobile. And if I try to navigate to this website, it should ask me for my Microsoft credentials. This is just an internal tool that'll be used by by some Microsoft employees. And so, yeah, it's asking me to log in with my Microsoft credentials. And what's cool with Azure, I can basically just toggle this. So let me click into it. There we go. So this authentication authorization, it's turned on. And specifically, I'm using Active Directory. If you wanted to, you could do a social auth or something like that. But check this out. If I just turn this off, save it, and shoot, I forget the URL for my website. Let me launch the website again. And
go back a couple, hold down the back arrow, or whatever.
We got it. So navigate to the website again. Should let me right in. And there's the website. So this was actually pretty easy to do just because we have this literal toggle in Azure. But this requires you to have an account already. So that's also one of the reasons why it's super easy. Let me show you what I'm doing in Git Trends, though, because let's see. Let me think ahead real quick to make sure I don't give away any API keys. Yeah. Okay. So in this app, so I'm using Azure Functions, serverless functions for my APIs. So things like certain things need to be authenticated, certain things don't. So things like I keep a URL there's a little intro video when you first launch the app that shows you basically just how to use the chart, like how you can tap and drag or how you can zoom in and out to see more data, just kind of like a little onboarding experience. And I keep the URL for this stored in the cloud, because if I want to change the video, then I can just swap this out in Azure and I don't have to release a whole new version of the app. If the URL was hard coded in the app, I would have to release a whole new version of the app. But so this is just anonymous. So anybody can hit this API and get this video URL. I don't know why you'd want to do that, but you're welcome to use my video anytime you want, because it's an anonymous API. There's certain things that I want to keep hidden, and Azure has or specifically Azure Functions allow me to increase the authorization level. And so to do this one is what I use to pass in the Sync Fusion API key, because I do have a paid Sync Fusion account. And when you have a paid Sync Fusion account, they give you a special key that you have to load into your Sync Fusion controls. Otherwise, let's see, I don't know if we caught it earlier. Come on, Android. Force quit. There we go. Because if you launch the app without that API key, you'll get this warning. There we go. Get past the splash screen. Boop. And I give you a little heads up that you might get a preview warning. But if I click on one of these, there we go. Sync Fusion. This is kind of their way to make sure people are using or paying for the service, right? So I keep these API keys, again, stored in the cloud so I can rotate them if I have to. Like if an API key gets compromised, I want to be able to rotate it. And again, if that was hard-coded into the app, then I couldn't. Plus, if I hard-coded into the app, well, this app is totally open source. So then anybody would have access to my API keys. So this works by essentially blocking anybody that hits this API without a specific API key. You can't get my top secret Sync Fusion APIs. So, I mean, I joke earlier when I said that's a topic for a whole nother meetup. All right, actually, I'm happy to come back and we can chat more and dive into it deeper. But yeah, authentication is really tough. And I think one of the things I'm fortunate with in this app is when you log in, you're logging into your GitHub account. And so I didn't have to actually create a authentication server, because GitHub's doing that for me. And I just follow the OAuth flow. OAuth is kind of this authorization standard. And so I just basically tell GitHub, I'm like, hey, this user wants to log in with their account. And GitHub goes, okay. Asks the user for their credentials. You'll actually notice my credentials are now cached, but you'll notice it launches the browser. OAuth always will launch a browser because that prevents me as the app developer from ever seeing your credentials. So certain developers don't like that OAuth launches the browser, and they will do what's called an implicit workflow. Don't do that, because if that app developer is malicious, then they could have code that logs your password to wherever, and then they just got your login info. So yeah, OAuth launches the browser. There's just basically, I just send the user over to GitHub, ask them to authenticate with GitHub. And then what GitHub does, GitHub just tells me as a mobile app developer that says, yep, this is Brandon Minnick, or yep, this is Ari. And then it gives me an authentication token. So I never see your username and password. OAuth kind of handles that for me. And so that's one way to do it. You can always have a social login, like GitHub, Twitter, Facebook, Google, somewhere, some service that handles authentication for you. Or in the case of that website we were showing earlier, you can use Azure AD, which just want to make sure I turned it back on. So good question. Yeah. All right. Maybe we can queue that up for a future meetup, because that is a very complex topic that
Applications are
all sorts of answers.
Now, to be fair, if you don't want to use social login, and you don't want to use, federated logins or Azure Active Directory and that stuff, which those are cool. they've got a learning curve, but there's a lot of libraries that'll make it really easy, including Xamarin Essentials, and it's a web authenticator that's just built in, takes care of all this stuff for you. But let's say you've got just using ASP.NET, not ASP.NET Core, but just traditional ASP.NET with Web API, and it builds that whole what do they call it, OWIN, set of along with bearer tokens and so forth. Refit is very easy for handling that. So you can use Refit to just tie it to the token endpoint of the ASP.NET web API site that gets built for you, that comes with authorization and authentication provider out of the box. It's all taken care of for you. Now, when it comes to managing users, that's a different thing. There's examples that handle that for you that also will sometimes come out of the box. I think at one point there was something there, but then at one point there wasn't. I don't remember. I ended up just writing my own stuff. Andy Framework has its own identity context that will build all that. It'll build the ASP.NET users roles and everything in your database and take care of all that for you. And if you just take a look at how that works in the traditional ASP.NET web API default project, you'll be in good shape there if you just need something simple.
Yeah, I think the best advice I can give you.
I don't know why ASP.NET Core didn't have that. I think you have to wire that up yourself. I could be wrong. I never saw it like working great, but then again, I haven't played with it enough to say.
Yeah, I think the best advice I can give anybody that is new to user management, authentication, authorization, don't create your own tool. This is very complex stuff. I mean, I use it, but I'm not an expert in it. And so make sure you leverage the existing tools. Like I already mentioned, Entity Framework has tools built in, Azure has tools built in, AWS has tools built in. Leverage the tools made by the experts. I mean, if you are a security expert and you know everything about this, go for it. But I'm not. And this is something that is quite literally what gets most companies burned. Like when you hear about like data breaches, probably the biggest attack is a phishing attack. And then it comes to just like, you never change the default password on your user database. Like it was password or admin. Like, yeah, that's how then like companies like, well, I won't throw any company under the bus, but major corporations leak all this user data, and it's things, and it's our data. It's just like my credit card info, my address, all my private data that I trusted you with is now gone because you tried to roll your own service. So yeah, don't try to roll your own service. Stand on the shoulders of giants, especially when it comes to security.
Yeah, they have the budget to protect you.
Yeah.
If anybody remembers that the original versions of SQL Server, the default SA password was nothing. It was empty. There was no. So
oh gosh.
Yeah, that was the built-in with SQL 7, and I think SQL 2000. It wasn't until like SQL 2005 or SQL 2000. No, it was SQL 2008. I think it was SQL 2008 is when you weren't allowed to set a blank default password without like some UI warning going, whoa.
It's terrifying.
Who would ever have access to the database server on the network?
Good question. Anything about .NET Maui or multi-targeted projects, Ari?
I haven't seen any questions come through. I'm excited about the multi-targeting, especially what looks like a UI that makes it not suck. So I didn't really know anything about the multi-targeting till tonight, actually. Like I had heard it, but
cool.
No one ever pointed out to me, like, here's how it's structured. And now I'm like, oh yeah, it's one of those things you kind of have to know how to set up the CS proj, and then, blah, blah, blah. But it looks like Maui will bring that over into the UI, which would be wonderful. Oh, here we got a question. Do you have a good app testing for security to check your app? I don't think there's an app that really test the security of your application. I think there's, if you haven't checked it out, go check out the OWASP, you know, what is it? The application security best practices. I got to remember
Top 10.
the top 10 OWASP best practices. Definitely look at that. Dave says, excellent presentation. Brandon.
Thank you, Dave.
Woohoo.
Thanks for sticking around.
Yeah.
We took a 1 hour meetup, lasted 2.5.
It is what it is. Yay. You can't get in the way of knowledge. But if you're concerned, I mean, follow the best practices for application development right there. What Brandon's showing you, those top 10 web application security risks, those to a good extent also lean into mobile. You can also build, there's tests that you could build. If you're part of a corporation, there's actually firms that will do testing, security testing, penetration testing against your application. It's not necessarily cheap, but there's some best practices. For example, not sending things in plain text and non-SSL. iOS won't even let you do non-SSL by default anymore. So,
Android too.
Android. Oh, is Android requiring that now? I mean, I was like, gosh, if
I think
using
Android 10,
HTTPS, you got to ask yourself why. In this day and age, it's 2020. Why are you not at least using SSL? Other things that you can do to protect your data, using certificates for your API authentication, that you can revoke. Azure Key Vault can come in handy there. Not storing credentials in the application. If you do store credentials,
don't put them in source code.
Store a hash. Never check in your code to a public repo that has your credentials in it. Again, things like Key Vault will help you there because you can keep your secrets out in the cloud, and when you build, it'll automatically inject the secrets into the build process and never keep them in the cloud. I think there was there's services out there that what they do is they just go through all the public GitHub repos and pull credentials out and go attack sites. And I think there might even be a public shaming site that does it too. Some of this is common sense. But you know what? I think sometimes it's not common sense till something's happened, or someone who knows better than you, especially if you're new to this. This is where code reviews become a very good thing. It's good to get a sanity check from other developers, even if you're a senior engineer or an architect, etc. You tend to be too close to your own code, so there's things that you'll miss because to you everything's great, and it makes sense to go and say, hey, so and so or another so and so that you trust, if there's credentials in there, would you, here's a pull request, comment on my code, let me see if I can fix it. I think that kind of collaboration with other developers can help. And just like you're asking here, what would best practices be? What solutions are out there? Ask people like us. I think that entire thing is also another entire presentation. Secure your app, writing secure code. There's actually a book from Microsoft called Writing Secure Code. It's a thick book, and it talks all about all the vulnerabilities. It talks about buffer overflows. It talks about SQL injection. It talks about replay attacks. It wasn't replay attacks, but it was like XSS, right? XSS attacks. There's a lot there, but that top 10 OWASP, it's so important. Like, there's a reason number one is injection. Like, if you're building an API, don't trust anything coming from the web at all. Always sanity check your data. Check, never assume that it's clean. Everyone wants to attack you. Not everyone, but it just takes the one person to get through. So code defensively, especially if it's going to be an API or a public facing where you don't control it. Any other questions from anyone? And ASP Nerd, I hesitate to go and recommend anyone just because that's not really my forte. I know that I just worked with a company called Decra. They do it. There's others that are out there. I'm not saying that Decra is the only option. There's a bunch of them. I mean, there's consulting terms all over the place. But you should really just go first. Start with the less expensive approach of reviewing your own code and going, do I feel this is secure? Like if I wanted to break into my system, could I get past this? And I think, like if you immediately go, oh yeah, I can just do this. That's a hole you need to pass. Yeah.
Definitely.
Yeah. Any other questions? Anyone? Bueller? And now we have to wait the 15-second delay because we said it.
That's right. I mean, if you do, I included my Twitter handle on the stream here, so feel free to shoot me a tweet, send me a DM. Always happy to chat about Xamarin stuff, C# stuff, .NET stuff.
Awesome. Brandon, thank you so much for your time. We'll make sure that this video gets uploaded. And I know, actually, I think you're presenting in another couple months for Indy Xamarin, and then another couple months after that. So,
that's right.
Hey, so if you check out the Indy Xamarin site, we've got all those presentations listed. Very excited to have had you tonight, and especially for future sessions. Thank you, Brandon.
Love it. Thanks again, Ari.
Yay. And now I don't know how we actually stop the event.
I'm in the background. You can't see me. Bye.
Thank you all. Have a wonderful night.